Hey guys, I'm going to walk you through lesson 6.5, which is on basically how to work with applications of quadratic relations. Okay, so what I have here is I have a parabolic structure, okay, and we're going to go through example one, and I'll also show you how to do something on decimals as well. So basically we're going to take all of our key points that we've done in the last couple of sections, so key points such as vertex, axes of symmetry, zeros, y-intercept, maximum, minimum value, yeah, I think that's it for now. And we're going to see how that applies in a real world situation or in a word problem setting. Okay, so something that you can interpret here, we have the path of a ball that was thrown in the air is modeled by the graph below. So basically, you can see that many things in sports context does definitely deal with parabolic structures, where you take a ball, you can kick it into the air, reaches a max height, and then it descends downwards. Okay, that could be for a football, that could be for a basketball, volleyball, but that generally is actually what type of parabolic path it takes in the real world context. Okay, so what we're going to do here is we're going to consider what this graph states. So the y values represent the height, so that represents the height in meters that the ball takes, and the x values represent the horizontal distance. Let me just label that for us. Horizontal distance in meters. Okay, so we want to figure out what was the maximum height that the ball reached. Okay, so that would definitely have to deal with looking at our vertex. And with our vertex, you can see here, it does reach a max height at 9 meters. If you find your vertex, which I've connected here for you, is at 10, 9. The y value is actually what answers this question. So we would say max height reached at 9 meters. Okay, so always interpreting it back to the units that the question outlines for you. How far had the ball traveled horizontally to reach that maximum height? So from 0 to 10, it took 10 meters of horizontal distance to reach that vertical height of 9 meters. Then we want to figure out what horizontal distance did the ball travel before it hit the ground. So again, if we consider the y-intercept, so the y-intercept is about 1.5, so we can think there was a person that was about 1.5 meters in height. They take a ball, they throw it into the air, it reaches a max, and then it eventually falls back to ground level. So from 0 to 10, and then from 10 to 21, so that's 11 meters, what we're going to do is we're going to add those two distances together, which means that the horizontal distance that the ball traveled before it hit the ground was actually 21 meters. Okay, so it's all about interpreting the wording that the question provides to you and just ensuring that you're working through the application question appropriately. Okay, for this one we're actually going to draw a little picture to help visualize what's actually happening here. So the arch support of a bridge can be modeled by this equation. So I'm just going to draw a bridge, and this equation is going to be represented by my drawing, where y is going to be the height but in feet, and x represents your horizontal distance and also in feet. So this is just for a visual to understand what it could look like. Now, a vertical support post is to be installed at 40 feet. So if this is 40 feet, I want you to think there's going to be a vertical support that's going to be posted, and we want to figure out how tall this support should be. So we can actually do it in two ways. The first way would be using the equation. So I'm going to take the equation that I have, so y equals negative 0.024x squared plus 2.4x, and if you don't already see it, you'll notice that the 40 feet mark is along the x-axis. So I'm actually going to replace x with 40, and then I'm going to solve. So I'm going to go back into the equation, and instead of x, I'm going to replace it with 40 meters, and that will actually tell me how high this vertical post will be. Okay, so I'm going to take the equation here, I'm going to sub in 40. Okay, so in your calculator, you'll notice in two places I've substituted x in for 40, and I need you to calculate that. Okay, once you calculate it, you can see you will come up with 57.6 feet. So you could say, therefore, the support posts should be 57.6 feet tall. Okay, now method 2 is to use a graph. So I'm actually going to show you what this looks like in Desmos. So if you go to desmos.com, I've already pre-populated it for you. So you see typing in your equation, you can use these buttons at the very bottom. I just copy the equation into that bar, and from there we have graphed our parabolic feature. Okay, if we were to look at where our x-intercepts are, so we can say there's an x-intercept at 0 and 100. Our vertex would be at 50, 60, but this particular question wants to know at x equals 40, so I'm just going to trace it, see how close I could get. Oh, I just had it. 40 and 57.6. Oh, I just had it. There you go. Okay? So once you see that through a graph, you can also use the graph on Desmos to help figure out what that solution should be. Okay? So I'm going to post for you some questions to complete. Please just do them at your own will. And yeah, that's all for me for this section.